My dear research students, we are going to discuss how to estimate exploratory factor analysis using SPSS syntax. EFA uses correlations as the unit of analysis, so we are taking the correlation matrix from table 2.1 from CFA by Brown. Please see table 2.1 taken from CFA by Brown. Intercorrelations among four behavioral observation ratings of depression. In this basic example, four behavioral observation ratings D1 to D4 have been collected on 300 individuals admitted to an inpatient psychiatric facility. The four ratings are hopelessness D1, feelings of worthlessness or guilt D2, psychomotor retardation D3, and sleep disturbance D4. These four clinical ratings or indicators are moderately intercorrelated. It is conjectured that each of these ratings is a manifest indicator of the latent construct of depression. That is, each of the observed symptoms, e.g., hopelessness, worthlessness, has the shared influence of depression. The single latent variable or factor that accounts for the intercorrelations among these observed measures, the only reason the indicators are correlated is that they share the common cause of depression. If this latent variable was parceled out, no relationship among these indicators would be seen. IBM SPSS Statistics 20. Wait. This IBM SPSS Statistics is now opening. This is version 20. Now cancel, then go to file, new, syntax. Now copying the syntax for estimating exploratory factor analysis, and this is the table of correlation matrix taken from Professor Brown. Now we click on run and click on all. This gives us the output, the factor analysis, the communalities, the total variance explained, then the factor matrix, and then the table for goodness of fit test. Now let us discuss the results in brief. Please see output under factor matrix that provides the factor loadings for all the four clinical ratings D1 to D4. EFA, the factor loadings are completely standardized estimates of the regression slopes for predicting the indicators D1 to D4 from the latent factor, the depression, and can be interpreted along the lines of standardized regression beta or correlation coefficients R, as in multiple regression or correlation analysis. For example, the factor loading estimate for D1 or hopelessness was 0.828, which would be interpreted as one standardized score increase in the latent factor or depression is associated with an 0.828 standardized score increase in hopelessness or D1. When we square the factor loadings, it provides the estimate of the amount of variance in the indicator accounted for by the latent variable, e.g. 0.828 square equal to 68.5% variance explained. In factor analysis, the amount of variance in the indicator explained by the common factors is termed as communality. The total variance equal to common variance as explained by latent variable plus unique variance. For example, the common variance for the indicator D1 is 68.5%. The remaining is known as unique variance. Unique variance is equal to 1 minus common variance. So, for the indicator D1, the unique variance equal to 1 minus 0.685 equal to 31.5%. Unique variance is equal to specific factor plus measurement error variance. Professor Brown says that it is important to note that EFA and CFA do not provide separate estimates of specific variance and error variance. The model estimate of variance VAR of an indicator, say D1, is equal to common variance or communality of D1 multiply with variance of factor multiply with unique variance, that is equal to 0.69 into 1 into 0.31, that is equal to 1. Because the EFA model is completely standardized, that is, When variables are standardized, their variance is equal to 1. Similarly, the model estimate of the covariance or correlation of D1 and D2, that is COV within bracket D1 comma D2, is equal to factor loading of D1 multiplied with the variance of factor multiplied with the factor loading of D2, that is equal to 0.828 into 1 into 0.841, that is equal to 0.696. The acceptability of factor analysis model is determined largely on how well the parameter estimates of the factor solution, e.g., the factor loadings, are able to reproduce the observed relationships among the input variables. For goodness of fit, we use the classic goodness of fit index, that is chi-square. The null hypothesis H0 equal to the implied predicted covariance matrix equal to observed sample covariance matrix. So, a large chi-squared and rejection of null hypothesis is desirable. In our case, chi-square value is equal to 0.2031, degree of freedom equal to 2, and significance is 0.9035. That is, the value of chi-square is too low and the significance is not appropriate, that is greater than 0.05. So, null hypothesis is accepted. Hence, our model is fit. This banner indicates the details. My dear research students, you can contact me only for PhD thesis work for those subjects which require data analysis, model development, estimation and interpretation, etc. on payment. Online classes will be started shortly.